Okay, good afternoon, everyone. Thank you, Mr. Chairman, sir, for the opportunity. As we can see from the slide, the title of my talk is Interweaving Cultural Astronomy and Science Communication in Informal Science Education. My name is Lauren Kimi. I am from Mizoram Science Center. Let's have a quick look at our Science Center. This was established by the Government of Mizoram and National Council of Science Museums under Ministry of Culture, Government of India, and the Science Center was inaugurated in the year 2003. And today's talk will be about how we are bridging tradition and technology in space science communication. As we all know, the planetarium is for the general public and especially the school children. So we are trying to do this through the planetarium shows. The National Council of Science Museums has taken the initiative to establish the Taramandal and the digital planetarium at our center. Now the Taramandal is no longer working as we are concentrated with the digital planetarium. And the technology that is being used there is shown in the slide. And as the previous speakers have mentioned, we also face challenges, lots of challenges regarding the limited fund availability for all the activities that we are doing. For example, the projector that we are using is only 2K, so it is very difficult to upgrade that from our side. So we are facing challenges in that way as well. We are showing planetarium documentaries in the local language. We have translated, and these are some of the documentaries that are being shown regularly in our in the local language. And we also have poster displays, and we also have kiosks, multimedia kiosks, where we showcase Hubble telescope, planets of the solar system, calendar of astronomical events, and quiz on astronomy. These are regularly utilized by the visitors, the public, and the school students. And we also have a Dobsonian astronomical telescope, and this is being used regularly for night sky observation, special programs that are being organized, especially during the winter time. This is the best time for stargazing in our state, where the sky is very clear. This is a very good program that we are undertaking. These are other educational activities that have been going on since the inception of the Science Center, which was in 2003. So all these things have been going on. But as I have said, the fund availability is low, so we have to stick to very tight budgets for these activities. The main talk for today is how we are using the planetarium in a dual manner to preserve traditional knowledge in a dynamic system, while at the same time trying to foster scientific inquiry and to awaken the curiosity in the onlookers. So the cultural astronomy of the Mizos started way back in the ancient days, where people used to sit around campfires at night. They did not have gadgets, they did not have devices, they did not have much electricity, so the sky was the sky would be very, very clear. So they used to share their tales. They passed down the tales to their children. That was their nighttime activity. So their stories need to be passed down to the future generations, so as to preserve them. So in the interactive digital real-time shows that we have using the sky control software, we used to tell the star stories, and at the same time try to incorporate the basic astronomical science with them. So as we can see, as I'm showing in the slide now, the preservation of the knowledge of the ancestors, way of life, their way of life and their thinking, that is what we are trying to do. So, for example, in the Orion constellation, we have stories, we have star names, we have stories, we have characters, and at the same time, while sharing these stories, we integrate concepts like the nebula. For example, in the Orion constellation, we have the Orion Nebula, and the life cycle of stars, how stars are born, how stars die, how stars explode by the supernova explosion. All these are integrated along with the storytelling. And for example, in this next slide, we have the Lipas constellation that is called the Sivokwang in the Mizo language. Sivokwang means a big bowl for eating food. So people in the modern day, especially the children, they do not, most of the people living in the city, they don't know what a big bowl looks like now, not to say the name. So in this way, we are trying to preserve the traditional knowledge, the way of life, along with the star stories. So for example, the Pleiades, we call that Siruk in Mizo, and the learning objective from the Siruk is how the forefathers used to mine the clay for making vessels, and they used to use the Pleiades, as you might have all know, to tell the time when to go home, at what time of the year the rice is to be planted, when, and so on and so forth. And at the same time, along with that, we talk about the open star cluster, with many stars, how they are young stars, how they are very hot, like that. So, and the next example is Venus and Jupiter, where we can talk about the planets and the stars, how they are different in their sizes, nature of the planets, and how they are moving around the sun, how we can see them in the evening, how they can appear in the morning, and all these along with the star story that we have, which is the this one, Tongmoy and Shangtuana. That is a love story, has romantic implications. So along with that, we can integrate that. So that is being done. So again, another one important aspect is the integration of religious beliefs. As you might be knowing, the Mizo community is predominantly a Christian community where the biblical teachings are ingrained at the children from an early age. At the preschool age, we have regular Sunday schools every day. Every Sunday, you might be knowing that on Sundays, the whole city is almost closed down because all of us attend the churches. So the teachings of the Bible is ingrained like that. So we are trying to integrate the biblical teachings and the astronomical concepts in that way. So for example, as I have mentioned, this has a direct impact on the receptiveness of astronomical information, okay? The religious belief and the astronomical implications, and that may evoke curiosity or wonder and sometimes disbelief among the onlookers or the audience. So that may result in questions being raised, and then the interaction can go on. So for example, we have the Bible verse in Genesis 1:6, he made the stars also, and in Psalms we have, he counts the number of the stars, he calls them each by name. We have these Bible verses, and then accordingly we can talk about the number of the stars and galaxies in the observable universe, how vast the universe is, like that. And in Revelation we have I am the Alpha and the Omega, the beginning and the end. We can talk about the speed of light, light year, concept of theory of relativity, distances of stars and galaxies. All these can be integrated in along with that. And other Bible verses are there. Can you bind the chains of the Pleiades? Can you loosen Orion's belt? And we can talk about the position of stars from the Earth's perspective, how they are looking we have the Orion's belt, we have the Orion's belt, how they might be very far from each other, even though we are looking from here, from the Earth's perspective. Again, we have heavens declare the glory of God. All these we can talk about stars and constellations. What is man that you are mindful of him, and the Son of Man that you care for him? We can talk about how small we are, how short our time is, our place in the vast universe. We can talk about size differences among the planets, stars as compared to Earth, and we have show how short span of a time the human have as compared to the vastness of the universe. We can talk about all these things in context to the Bible verses that they have been learning since their childhood days. And so this concept is especially very useful for interacting with the senior citizens, not only the school children, especially among the senior citizens. So again, we have some key inferences from the Mizo star stories, how people behaved, how the culture was in the olden days, which are not practice anymore, okay, from the star stories. For example, we have the Orion constellation. We could know that the rodent catching, the wild rat hunting was prevailing then, And we have the hunter killed by tiger, villages hunted for the tiger. All these are in the Orion story, okay? So in the Taurus constellation, we had the monkey hunting with dog. So the people back then used to hunt the monkeys with their hunting dogs. So like that, we have people digging clay for vessels. In the story, we have a landslide. So that means Mizoram is a hilly place. Landslides occur there. So that is again integrated in that story. We can know that from that. And we have Vanpui Saishua. This is an asterism which is made up of 5 stars. This is use of slingshots to shoot birds and small animals were prevailing then. Okay, and then we have the Corona Borealis, bow-like trap with its bounty, animals hunted and skin taken for various. All these are incorporated in the Mizo star stories. Again, we have like Milukai. From this story, we can know that the Mizos in the olden days were warring tribes. They were headhunters, and the villages have hunters and village chiefs, and best time to attack the enemies can be understood from the how the stars are arranged. Like we have Venus and Jupiter, I told you before, dating during planetary conjunction, was taken as a sign of prosperity, and warring with neighboring villages were very prominent. Okay, all these inferences could be taken from the star stories, the different star stories. So again, this I will not go into detail. So we had dark skies in the absence of electricity and modern devices and gadgets. That was a very, very important aspect back then. So we have recently published a book, which is History of Astronomy of the Mizo People. This is an edited book. I am one of the editors. As you can see, my colleagues are this is from the Mizoram University Department of Physics, and this is Dr. Martin George. He's from the Hive Planetarium from Australia. So I have a few copies of this book with me. So if any of you is interested, you can kindly contact me. So that is all for my presentation. Thank you.
Thank you very much for a very nice talk and finishing it well in time.
Okay.
We have time for questions. Anybody have questions? Okay, over here, please.
Okay.
Yeah, so in one of the slides you showed that you're correlating the level of comet to the depth of village chiefs.
Yes.
Can you elaborate that, what you explain to the kids?
Yes, yes. In the olden days, the Mizo people, they thought that the comet was one kind of a star, okay? Simeko, that is the star with a burning tail, as the name signifies. So whenever there is a comet appearance, they thought that was a bad omen and that the village chief might die. That was their belief. So it's not that every time the comet appears, the village chief would die. It's not that, but they thought that the village chief might die. So that was their belief. Okay. Okay. Yes, please.
Hello.
Yes.
Yeah, this is Avitas Gupta from SDT University, Gurgaon. So that's a nice compilation of different stories and stars relating to that. Is there sort of other folk tales, or how did you compile this? Or how did you compile these specific stars?
Yes, we have very limited written documents regarding the various star stories of the Mizos. So as I mentioned in this book, we try to collect whatever information that we have and put it in this book. Okay, this is only around 3, 4 publications were there prior to this, which talked about the star stories. So we collected from there, and in this book we also invited eminent writers and academicians from the Mizo community, and we also have Dr. Himadri Das from Assam University, and then Dr. Martin George. All of them have short chapters where they write their knowledge about the stars. Okay, like that. In that way, that is
I just
combined.
wanted to understand the process.
Yes, yes. Thank you.
I'm Ganguly from Calicut Planetarium,
Yes.
Regional Science Center Planetarium. So whatever you have explained there, the other planetarium there, did you transform this into a planetarium show of any type?
Actually, the normal planetarium shows that we have, as you might be aware, are documentaries, okay, that I have told you that we have translated some of them in the Mizo language. So normally we show them, but if I am there and if my other colleagues are there, okay, it's not that every day in each and every session we are there, but if we are there, we do the star show, the planetarium show, the real-time interactive star show. We do that for, depending upon the audience, we do for if there are small children, we the topic of the talk, I mean yes, the how we are presenting is different as we are as different from the if the audience is a more senior citizen like that. So we do that accordingly, and we do the real-time planetarium interactive show, and after that we continue with the documentary show. So that is in a two-step manner. Yes, please.
We can take it a day. We'll dive in.
Okay, okay.
Thank you very much.
Thank you.
Next speaker is Jen Kamli.
So, I am in the business of communicating astronomy among the commoners. Now, real commoners, because they may not have studied astronomy, they may not be from scientific background, and we deal with these people and we try to communicate through a medium. So today I will be telling you how actually we do with some of our products and some of our shows, how we have done that. See, stars are available to all of us. We have Starry Night is a part of all of us. But we all come with our way of bringing up, upbringing, our beliefs, the cultural stories which we have learned. And taking cue from that, we have understood that if we take and we try to impart, if we try to rationalize that, we try to revise the beliefs, we have seen that there are a lot of encouragement among the people, and they do learn a lot of things which actually we want to show them in astronomy. So we do this through a medium called planetarium. But why does a planetarium matters when we have all this actual sky above us? The thing is that, so we have sky, there are limitations, there are weather conditions, light pollutions, we can't control the motions of the sun and stars. And so in early 20th century, a German astronomer called Max Walz, who approached Oscar von Müller, who has formed the Dostis Museum, to make a device which can actually mimic the actual motion of the stars and the planets in the sky. So from Carl Zeiss, we had Walter Busfield, who in 1923, who succeeded in demonstrating a machine which can do this. And there the full thing changed, and people could make all the simulations what are possible in real time to understand the sky. They could make the retrograde motion, they could go to the any dimension, any point of time, ahead of time, or they could come back. So this full thing got actually changed with this machine. And in later 1947, Armand Spitz, that machine was a pretty costly machine, it couldn't be afforded, it was not popular among a lot of people, so it came down, and the Spitz has made very cheaper machine which went even to schools and people had that. So that was the way actually the planetarium got. It's a very powerful medium where we can control the things, and so astronomy popularization got much better with the use of planetarium. And planetarium enabled people to develop planetarium shows, their own shows, taking the beliefs of their cultures, of their local land, where the people are residing. They know actually the population there. Based on that, they can build the planetarium shows. And what we have also tried to do that, I will show you a few examples of that in this talk. Now, why this is Calicut Planetarium, where actually I come from. Sorry. Anyway, there is a movie, it is not getting played now, so we leave it. So it was established in 1997, and so far we have actually developed 36 in-house planetarium shows based on this particular belief of storytelling, which we found out to be more beneficial for development and proliferation of astronomical concepts and knowledge. So what is the philosophy of our storytelling? Now, we start with actually people, what they know, the demographic divide in the, demographic bifurcations in the population, and maintaining the scientific accuracy, and starting from the point what they know, we try to make different types of shows. We have shows in diverse topics, which were from very initial stage. Actually, a kid wants to know a lot about astronomy, and to more advanced, like moving to the edge of the universe, or now we have gone to cultural part also, which I will be discussing. So these all things actually led us to promote how actually rational thinking could be integrated, astronomical knowledge could be refined, beliefs could be revised, and ultimately the logic could be implanted to how actually the astronomy things works. So storytelling, as we have seen, these narratives are already there. When we study about constellations, we study about various types of mythology associated to this. So these were all done to actually remember the framework on which we want to remember the people in ancient days. They wanted to remember the sky, based on which actually they tried to understand, and they found out the recurring appearance of sky that forms the framework on which the planets and all move, and ultimately they could find out something new object. So this framework was made to learn and made to remember through these stories. The stories are actually better for humans to understand concepts which are more abstract, and the local cultures make astronomy relatable to people. They found the connection between themselves and what is going on in the sky, and they try to understand and comprehend from there. And it appears to them more meaningful than getting abstract. So one of the first ventures which we have done was a show called Donna and the Universe way back in 1999. It was a conversation between a curious small girl, say a middle school girl, and her uncle, who is supposed to be an astronomer in what we have said Kavalur Observatory there. So the curious girl goes on asking a lot of questions like, see, where do we reside on the surface of the earth? And they say that it is on the top. Then why do we not fall away from the earth? Then you bring in the concept of gravity. And then it goes on like our planets and other things, how comets occur, what are the comets and what are the shooting stars. All these things goes on one after one. And this was a story based on actually what the child feels. He says to her uncle, and uncle tries to say him about what happens and what is the thing. And it was done in a setting near the Calicut beach, where the horizon is clear and people more understand about that. Then our next show was on Destination Moon. See, in Calicut, we have a large number of people the adjacent side is actually Malappuram district and Calicut. There are a lot of people who they like to know about moon, and due to their religious beliefs and all, they are more inclined to know about many facts about moon. So for that also we have made a show to cater to a specific population, but moon is a very popular topic. And in this particular show, actually we started, how we start the show is also important. We tried to make it a little different from what we have done in the previous day. So we wanted to bring it some type of artistic touch to it. We started with, the Malayalam show started with a song which is culturally popular among in that particular land. And for the English show, we have started it with a poetry literally linking it to the moon. Then we came around the stories of mythology, and ultimately, we came to the science of the moon, and slowly actually we went into the deeper aspects of the moon, and ultimately the moon travels and all. So that was a way in which we developed this particular show. Then we also thought that we should develop some shows which are about the events which are popular in the culture. Kerala has two events which are particularly celebrated by each and every household in that particular land. People celebrate Onam and Vishu. And of course, Ramzan is one of the very popular celebration there. So this Vishu and Onam, and in particular Onam is more grander, and there is an astronomical significance of Onam. The astronomical significance is somewhat like this, that the sun should be in Chingam, that is in Leo constellation, and moon should be near the Attam nakshatra, that is Harsha, that's our nakshatra series. So we made a planetarium show on that. We actually showed the path of the sun. We showed about the mythology of Mahabali and all those things, whatever mythological impact to start with. And then we went to sky and we showed that how actually this Onam is decided. What is the astronomical significance of Onam? We introduced ecliptic, we introduced sun, we introduced how sun moves through various constellations, we introduced nakshatras, we introduced how many nakshatras are there, and then we actually showed that in this particular junction, people actually, when it is in this particular form, people celebrate this particular festival. So that astronomical festival, and in that way, we communicated some part of other astronomies also, which people came to know whilst actually studying about their, knowing about their culture. Similarly, one project which actually I love to work on is Ramzan and Islamic astronomy. Ramzan is very popular. A lot of big population of people are of this faith, and they want to know about moon. They come and go on asking about a lot of things about moon. So the criteria of Ramzan is equally important, when we will see the moon, what time we can see the moon, how is the criteria. So we answered that and we made a show on that. Ultimately, actually, what we did is that we saw the problem from various angles. How actually Islamic astronomers, actually a lot of time has been spent by Islamic astronomers to find out exact time of the Ramzan, when it should be celebrated, which day, previous day, this day, next day, how the criteria should be there. They have even used satellite imagery for predicting that. So there are a lot of things they have done. And we brought it in front as a whole. Actually, that problem is not yet unsolved problem for the full community, but still we have upholded that problem. Then there are other problems of prayer timings, how they moved, and the direction of their actually Kaaba towards the Makkah, how they are decided. And then there were other actually people like there were other astronomers in Arabic origin who has contributed immensely, or there are certain historical importance of those particular things, of those particular stories which they should know, or which all the people should know. For example, in 1020, there was in Cairo there was a observatory built by Fahmid Caliph. Now, as soon as they built that observatory, what happened is that somebody got stabbed there. A comet came, many people got killed, and ultimately they ordered the observatory should be broken, though there were some works going on there. So in this way, actually, a good progress in astronomy got hampered. But well, there are other people like Nasir al-Din al-Tusi, Ulugh Beg, and they have done a lot of works on astronomy. Even a lot of stars in our sky are having Arabic names. So these all aspects are actually upholded, and we actually made a show on this. Then kids, we have a lot of kids coming to the planetarium. So they don't understand big theories or big things shown to them. And I don't know, there is a common parallel on astronomy to put time machine in its place. Let us move with time machine from one place to another. Now we thought to forgo time machine. Superman is known better among children. So why not use Superman? So we used Superman to transport one person from one location to another, and we developed a show based on this movement and the other aspects of astronomy, and that was our kid show. So the storytelling in astronomy come when they like the show, they repeat, they ask questions, they discuss within our community, they discuss with the planetarium persons, they come for the sky information technology, good animation techniques, and all these are embedded in new softwares which are available with the planetarium. So people can actually make good use of them and develop beautiful graphics so that people will like it. And children really like those things. And they understand it better and they remember what have been told much better.
There was one more quickly. Okay.
हेलो नमस्कार, मैं रश्मि हूँ स्टार स्किट्स कंपनी की तरफ से। मेरा एक सवाल ये है कि जो अपकमिंग जो थ्रेट आ रहा है वो है लाइट पॉल्यूशन का, और जो नॉर्थ इंडिया में है वो आपकी स्काई क्लियरली दिखता है, तो डार्क स्काई प्रिजर्वेशन के
अच्छा, तो आपका क्वेश्चन डार्क स्काई किस तरीके से मीन्स प्रिजर्व किया जा सकता है, शायद नहीं, शायद उसके लिए एक अलग टॉक है, मैं बता सकता हूँ, पर वो टॉक मेरे साथ लिंक नहीं है। तो मेरे साथ जो टॉक था वो प्लानिटेरियम शो डेवलप करने पर था, तो मैं कह सकता हूँ इसको, पर एनीवे समबडी विल स्पीक ऑन दैट, सो आप उनसे पूछिएगा तो अच्छा आंसर मिलेगा आपको।
बाद में डिस्कस कर सकते हैं ओवर टी। थैंक यू वेरी मच। यस, नेक्स्ट टॉक,
Good afternoon, everyone. Myself, Shudipta Shaha. I have come from Regional Science Center, Bhubaneswar. This is a science center, and in this science center, we have a plethora of activities. Among them, one important activity is about astronomy and sky watching. So, while doing some shows or planetarium shows with regard to this astronomy, sky watching, we generally do studies into the ancient Indian system of astronomy, how they worked, and how they have uh, contributed to the development of astronomy in India. So, on that topic, today I will deliver a lecture on Samanta Chandrasekhar, the forgotten traditional astronomer of Odisha. So, as we all know that history of India's astronomy is started long ago with the time of Vedic period, and it all started with human curiosity, ingenuity, and perseverance. So, from the time of Aryabhata, Bhaskara, Barahamihira, Indian astronomers have navigated through the celestial skies and tried to unravel the mysteries of the cosmos. Now, in this range, we will have one astronomer who is hailed from Odisha. His name is Samanta Chandrasekhar. He belongs to the 19th century time period, but he is considered among the scholars in the extraordinary league of naked eye astronomers like Copernicus or Tycho Brahe, because as we will go forward and see that he has used only his eyes and some small instruments that he has made with his own ideas to have a look on the sky, and he have done all those calculations based on his instrumentations. So everything he got attention, though he was born in 1835, he got attention at around 1868. Because, why? Because at that time, on August 18, 1868, there was a total solar eclipse which is visible from India, especially from the South India, and it is partially visible from Odisha, the state of Odisha. And there was some predictions, there was some traditional almanacs, we called it Panjika, that was available, and they have mentioned the timings there. So there is one traditional Panjika which is used at that time that have mentioned a certain time, which is around 10 am in the morning, the start of the eclipse. And the new Panjika, it stated that it will start at around 8:29 am and it will go up to 11:46. So when the actual event occurred and they have observed the timings, so they got the timing as morning in 8:47 is the starting time and end time is 11:32. So the prediction of the new Panjika is quite accurate if you compare it with the old Bengali Panjika. So the man behind that Panjika and these accurate predictions of the solar eclipse was Samanta Chandrasekhar. We, the people of Odisha, actually call him Mahamahopadhyaya Chandrasekhar Singha Samanta Harichandan Mahapatra, because these are the some honorifics given to him by different administration. Like Mahamahopadhyaya was given by the British administration. Then Samanta Chandrasingha Chandrasekhar was his family name. Harichandan Mahapatra was given by the Gajapati king of Puri, who was instrumental behind his work. But we fondly call him Patani Shamanto. As I told you, he was born in the year of 1835 on December 13 in a village in Khandapara. That is very remote, even for today's standards. So at that time, it was very remote. And he was homeschooled by a Brahmin teacher, and he learned Sanskrit grammar, Smritis, the Puranas, and this kind of thing. So the only languages that he knows was Oriya and Sanskrit. So all his works which he had done is only in Oriya and Sanskrit. So that is the main reason, apart from the local people and academia, people are not aware of his works. So what he was introduced to astronomy and astrology by his uncle at an early age, and soon he has completed all the traditional documents which are available in the Royal Library, like the Lilavati, the Bijganita, the Vyakarana, Jyotish. And he got interested in astronomy and specifically stargazing. So he started observing the sky and telling it with all the siddhantas or all the old written documents that are available with him. But while going through the observation, he finds a strange dissimilarity between his observations and the observations that were made at that time before with the available documents, like the Siddhanta ceremony, Surya Siddhanta, all of them were made at least 1000 years before his time period. So he saw that neither the planets or stars are in a position which was supposed to be, or not at the right time they are coming out and they are disappearing. So he tried to recalculate all these positions of the stars and he tried to rectify the errors. At that time he was only at 15 years of kid. So before going to his study, we have to just go through the 4 types of main aspects of positional astronomy, which is observation, calculation, instrumentation, and based on all these 3, theory and model. So unknowingly Patani Shamanto entered into the field because there was no formal education for him. So all what he has learned is only by his own inquisitiveness. So we will go to the instrumentation part. So Patani Samanta was unaware of the developments happening outside the Khandapara, and he made his instruments of his own. He was not aware of telescopes or other instruments which is available there. So he have to construct his own instruments. But the data he got from those instruments were surprisingly similar to the modern data. And one important thing is, in all the Siddhantas before, there was no description of the instruments by which they have taken the measurements. But he has done in his book Siddhanta Darpana, he has actually enumerated all his instruments very clearly so that anybody can make it and have a check. So with the help of all those equipments, he made observation and note down the data, and finally he made all these things into a book called Siddhanta Darpana. Now, these are some of his instruments. These are very simple instruments made from woods at that time. That is a chapa yantra, that is mainly meant for measuring time. This is also to follow the shadow of the sun, Golardha yantra. This is another chakra yantra, time measurement instrument. This is dhanu yantra. This is for the angle of viewing of the sun or the planets. So with all these instruments, after he has jotted down all his data for 8 years, so he wrote down all his findings in Sanskrit sloka in Odia script and made a treatise called Siddhanta Darpana. And it can be seen that at that time, though printing technology was available in modern cities in India, but he has chosen palm leaves for writing all his documents. And he has actually corrected all the errors that crept into the Siddhantas for a period of few centuries. So these are some datas and corrections which Patani Samanto has made into the positions of other planets. He kept sun and moon's sidereal periods the same, but he found change in some other planets. And also he improved the observational findings of sun's parallax. And one of the important thing of his research was finding the 3 corrections of moon, all 3 together. They are the evection, variations and annual equation. So as I was telling, this is the original palm leaf scripture or manuscript. It is. So he was not aware of telescope, he was not aware of modern advancement in astronomy. He never went beyond Katak and Puri. So whatever he did of his own. He did not get any help from any other scholastic people. And it was there. He made the book Siddhanta Darpana, but it was published 28 years after, just because of it was written in Oriya. So there is someone who need to be translated into English or local language that will be readable for everyone. So all these credits goes to Sri Mahesh Chandra Nayaratno, the principal of Sanskrit College of Calcutta at that time, who introduced Samanta Chandrasekhar to another professor, Professor Yogesh Chandra Ray of Katak College. So after some speculative differences, then undertook the task of publishing Siddhanta Darpana in Devanagari script with the financial support of 2 kings of Odisha, the king of Atmalink and king of Mayurbhanj. With publication of Siddhanta Darpana, Samanta's fame spread over far and wide. Now after this publication, he was mentioned in the 1899 British journal Knowledge, as they commented of all the numerous works of astronomy and that have been published in the last few years. This is by far the most extraordinary and in some respect most constructive. It demonstrates the degree of accuracy which was possible in astronomical observation before the invention of telescopes, because all these calculations are based on naked eye observations. Similarly, at that time, journal Nature writes, "What has he done after all?" asks the impatient critic. To him, I would say, is it not enough to find in this man a true lover of science, who, regardless of other people's unfavorable opinion of his work, their taunts, their dissociations, have devoted his whole life to one pursuit of knowledge, who has shown the way to the original research amid difficulties serious enough to dishearten men in better circumstances. So, actually, Professor Roy has compared it with Tycho Brahe, but they have told he should be imagined greater than Tycho Brahe. This is the sanad, or the British government has conferred him that Mahabhagyai. This is the sanad for him, and Harichandan Mahapatra was conferred upon him by Gajapati King. And in 1876, there was some this kind of conference among Sanskrit scholars and astronomers from Varanasi, Ujjain. And from that point of time, his almanac was accepted in the Puri Jagannath temple, and till date it is in use. So this is the original manuscript kept at our state museum, the manuscript and the stylus. And this kind of scripture was made in the, we have actually one planetarium dedicated to this man, Patani Samanta. So on the wall of it, this kind of scriptures were done. So he passed away on June 11, 1904, almost 120 years from ago. But whatever he has done for reviving the old knowledge and improvement of that old knowledge is really applaudable. But sadly, outside the state of Odisha and academia, he is not so much of popular. So this is my little effort to put him in the central stage. So thank you. Any questions?
Just one question.
Ma'am is there. No. He is basically, at that time, Odisha was divided into we called it Rajpad, means small princely states. So he was born in one such princely state in Khandapara. So though he belongs to royal family, and his library, there are every books are available there. And it is out of curiosity he started reading all those books. Yes, those books are available. All those are Sanskrit verses. Those are available. Yes. Thank you, madam.
Okay, yeah, let's end the session. Thank all the